Hello students, welcome to Evershine Coaching Center. Myself Faisal sir here. So dear students, today we are going to study the chapter real numbers. In real numbers we have got certain statement based problems based on Euclid division lemma. Is this clear? We have got certain statement based problems. I can call that as condition based problems. So let's begin. We can see here the question is, show that every positive even integer is of the form 2q. Every positive even integer is of the form 2q. Okay, and every positive odd integer is of the form 2q plus 1. Every positive even integer is 2q, and we have to prove this. If we take any positive even integer, we should get the answer in the form of 2q. And if we take every positive odd integer, it is in the form of 2q plus 1, where q is a whole number. Let's start. Now we can assume let a and b be the two positive integers. Okay, let a and b be the two positive integers. Now very simple, by applying EDA rule, Euclid division algorithm, that is Euclid division lemma rule. Okay, by applying EDA rule, what was the EDA rule? That is a is equals to b into q plus r. This is what our EDA rule, right? So what is the condition here? Where 0 less than or equal to r less than b. 0 less than or equal to r less than b. Now case 1. What is case 1 here? What is the case 1? Every positive even integer. What is the condition? Every positive even integer. Every positive even integer. Now I am applying this rule for even positive integer. If we are applying for even positive integer, what was the statement? I mean the answer should be equal to every positive integer, it should be in the form of 2q, right? So what is the value of b? The value of b is 2. Generally the value of b is 2, where q is a whole number. Okay, b value is 2. So what are the remainders? So the remainders will be, as we can see here, the remainder should be less than b. करेक्ट? देखो बेटा, हमना होना क्या है? पॉजिटिव इंटीजर होना. अब कंडीशन के हिसाब से कंडीशन क्या बोल रहा है? What condition is saying means if we are taking even integer, we should get 2q as the answer, right? We have to bring the answer in the form of 2q. So what is the value of b there? 2. Condition is 2q, where q is whole number, right? So r is equals to, what are the remainders? If b is 2, what are the values comes below 2? Less than 2. We get 0, we get 1, that's it. Because less than 2 means 0 and 1. If we want even integer, then choose remainder even number. If odd, then choose odd number. In r is equals to 0 and 1, since we want even integer, so we take r value as 0. We assume the remainder as 0. We consider remainder is 0. Now just apply in the Euclid division lemma rule. That is a is equals to, what is b? b is 2 into q plus remainder is 0. That is nothing but a is equals to 2q. Hence we got. Simple. Same thing. Positive odd integer. Positive odd integer. If positive odd integer, so what is the remainder we should take? Here we should take r as 0, right? So here r is 1. So a is equals to 2q plus remainder is 1. So a is equals to 2q plus 1. It's very simple. Hence proved. Are you getting, children? If we take even positive integer, we should take remainder as 0. If we take odd integer, we should take remainder as 1. Understood? Out of 0 and 1. Because B condition is 2q. B is equals to 2. So remainder will be 0 and 1. If for even, take remainder as 0. If it is odd, take remainder as 1. Simple. Thank you. Yes, children, we can see the next question here. Show that any positive even integer is of the form 4q. Any positive even integer is of the form 4q or 4q plus 2, where q is whole number. Okay, same procedure. Let a and b be the two positive integers. Two positive integers, right? So by applying EDA rule, what is EDA rule? A is equals to B into Q plus R. A is equals to B into Q plus R, where 0 less than or equal to R less than B, right? So what is the condition? We have only one condition here, only even integer, right? So what is the condition? Positive even integer, right? So what is the value of B here? The value of B is 4q. So value of B is 4. So what are the remainders? 0, 1, 2, 3. Less than 4 is 0, 1, 2, 3. अगर से b की वैल्यू 4 है तो 4 के अंदर कौन से नंबर्स आएंगे? 0, 1, 2, 3. Okay. Now we have to choose even numbers, right? We need to choose even remainders. Because even integer, we should choose 0 and we have to choose 2. Remainders we have to choose 0 and 2. Two cases. If it is odd, we have to choose 1 and 3. Now here remainder is 0. If remainder is 0, so what happens to A? So A is equals to B, value is 4. Q plus remainder 0. So A is equals to 4Q. That is what he asked us to prove, right? What did he ask us to prove? Prove that even integer, it is of the form of 4Q. It is of the form of 4Q. If we take remainder as 1, remainder as 2, because even integer, we should take remainder as 2. Case 2. If remainder is 2, so what happens to A? A is equals to 4 into Q plus remainder is 1. So A is equals to 4Q plus 1. Hence, proved. That's it. Thank you. Let me solve one more problem. Hi children. Now, let we start the next question. Use EDL to show that cube of any positive integer. Now here what is the condition? Cube. Don't forget, condition is cube. It means if you are going to cube any integer, here condition matters. In the previous case 2q, one case 4q was the condition. So here cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8 for some integer m. Understood? Now let A and B be the two positive integers. A and B be the two positive integers. Here he has not mentioned whether it is odd or even. It means we have to consider consecutive terms. Okay. Let A and B be the two positive integers by applying EDA rule or EDL rule. A is equals to B into Q plus R, where 0 less than or equal to R less than B. So what is the value of B? Q. That is 3. So what are the remainders? 0, 1 and 2. Right? If the value of B is 3, then the remainders are less than 3. कौन से numbers less than 3 आती? That is 0, 1, 2. Now case 1. A is equals to, what is B? 3Q plus remainder is 0. That is nothing but A is equals to 3Q. I will call this as equation 1. Okay. Same way, a is equals to, first what did I do? I took remainder as 0. Now I am going to take remainder as 1. So what happens? A is equals to 3q plus 1. Equation 2. Next, option 3. Here option 3, if r is equals to 2. So what happens? A is equals to 3q plus 2. That is equation 3. Now what I will do here, if I am applying remainder as 0, that is remainder as 0, so A is equals to 3q. If I am applying remainder as 1, that is r equals 1, A is equals to 3q plus 1. If r is equals to 2, then A is equals to 3q plus 2. Now what he has given here in the question, if we cube any positive integer, जब ये कोई भी equation 1, 2 या 3 को अगर से तुम्हें cube किए तो in case if we are cubing any of the if we are cubing these all the terms, then we have to prove the answer in the terms of 9m, 9m plus 1 and 9m plus 2. Sorry, 9m plus 1 and 9m plus 8. Okay. Now what I will do here, as for the given statement, cubing on both sides. I mean cubing for all the equations. Cubing for all the 3 equations. Okay. Cubing for all the 3 equations. So what was the equation 1? A is equals to 3q, correct? That is a whole cube is equals to 3q whole cube. A whole cube means a cube is equals to 3q. 3q whole cube. 3 cube is 3 into 3 into 3. 3 3s are 9, 9 3s are 27. Then this is q cube. Now what is the answer? If we cube this a, the first answer should be 9m. We want the answer in terms of 9m. So what I will do, I will write 9 here. I will write 9 here. Open the bracket. 9 into how much is 27? 9 3s are 27. Q cube as it is. Understood? So what happens now? A cube is equals to 9m. Okay? Because or where m is equals to 3 cube. If I am going to assume the 3 cube as m, then what happens? The final answer is 9m. Done? So simple. Nothing to worry. Same thing. What is equation 2? What was equation 2? A is equals to 3q plus 1. Correct? Yes or no? Again do cubing. A whole cube is equals to 3q plus 1 whole cube. Now in which form it is? It's in the form of a plus b whole cube. Yes or no? A means 3q, b means 1. A plus b whole cube. What is a plus b whole cube? A cube plus b cube plus 3ab into a plus b. Done? A whole cube is a cube. What is a cube? 3q whole cube. A cube plus b cube 1 cube plus 3 into a. A is 3 cube. B is 1 into a plus b. What is a? 3 cube plus b is plus 1. Now simplify this. 3 whole cube means 27. Q cube plus 1 cube is 1 plus 3 3s are 9 cube. 3 into 3q is 9q. 9q into 1 is 9q into 3q plus 1. Are you getting, children? Now one thing I want to tell you people, instead of writing 9q into 3q plus 1, what you can do, if you want you can solve in this step also, no issue, but still what you can do, my suggestion is try to simplify here itself. aq plus bq plus 3ab into a, 3a square b, correct, plus 3ab into b, 3ab square. So can we write like this also? If you want you can try with this method also, no problem. aq plus bq plus 3a square b plus 3ab square. A cube is 3q whole cube, b cube is 1 whole cube, 3 into, what is a square? 3q square. 3q square into b is 1 plus 3ab square. 3 into a is 3q, b is 1 square. 1q plus 3 into 9q square. Correct, no? 3 square is 9, q square. Plus 3 3s are 9q. 9q into 1 is 9q. So what is the final answer? 27q cube plus 1 plus 3 9s are 27q square plus 9 cube. Now one thing you should remember. What we should remember, what should be our final answer? We need the answer in the form of 9m plus 1. Correct? So what I will do, now what I will do here, 27 q cube third degree plus second degree 27 q square plus first degree 9 q plus constant. I am going to arrange in the order, okay, in the standard form. Now out of this 3, 9, 27 q cube plus 27 q square plus 9 q, I am going to take 9 as common. I am going to take 9 as common, okay. 9 3s are 27 q cube plus 9 3s are 27 q square plus 9 is already out into cube plus 1. So what happens now? A cube is equals to 9m plus 1. Where what is m? Because m is equals to 3q cube plus 3q square plus q. This is option 2. How it is? So simple, right? Yeah. Now what was the equation 3 we had? That is a is equals to 3q plus 2. Correct now? Now can we do cubing on both sides? A cube, a whole cube is equals to 3q plus 2 whole cube. A cube is equals to, it's in the form of a plus b whole cube, no? Just now we did. What is a plus b whole cube? A cube plus b cube plus 3ab into a plus b. That is a cube plus b cube plus 3ab into a, 3a square b plus 3ab into b, 3ab square. Correct? A cube, 3q whole cube plus b cube, 2 whole cube plus 3 into a square, 3q square into b is 2 plus 3. What is a? 3 cube into b, 2 square. Done? 3 3s are 9, 9 3s are 27 q cube plus 2 cube, 2 into 2 into 2, that is 8 plus 3 into 3 square, 9 q square. Okay. 3 2s are, can we multiply this both the terms? 3 2s are 6 outside terms. 3q whole square is 3 square is 9 q square plus 3 3s are 9 cube, 2 square is 4. So if we simplify, 27 q cube plus 8 plus 6 9s are 54 q square plus 9 4s are 36 cube. Shall we arrange in an order now? 27 q cube plus 54 q square plus 36 q plus 8. We want the answer in terms of 9m plus 8, no? So I take 9 as common factor. 9 3s are 27 plus 9 6s are 54 plus 9 4s are 36 cube. Out of these 3 terms I have taken 9 as common plus 8. So what happens? 9m plus 8. Any doubts? If we cube all these numbers, that is m is equals to 3q cube plus 6q square plus 4q. It's so easy. Done? Let me solve one more problem. The next problem here is, prove that the product of 3 consecutive positive integers is divisible by 6. We have to prove 3 consecutive positive integers is divisible by 6. Let me assume, okay, it's very important question, don't forget. Let x consecutive integers, he said no, he's saying 3 consecutive positive integers is divisible by 6, we have to prove. So which are the 3 consecutive integers? Let me assume, let x minus 1, x minus 2 be the 3 consecutive positive integers. We have assumed x minus 1, x minus 2 be the 3 consecutive positive integers. Now what is the condition? Here the condition is, what is the condition? The product of 3 consecutive integers, the product of 3 consecutive positive integers are divisible by 6, we have to prove. If you are going to multiply all these 3 consecutive integers, then that product should be divisible by 6. That is what we have to prove here, right? So what I will do now, so their product, what is their product? 3 consecutive positive integer product, their product will be x into x minus 1 into x minus 2. Option 1. Let we assume x is equals to 6p. Okay, let x is equals to 6p. Now what happens? What is the product? What is the LHS? X into x minus 1 into x minus 2 value. What it should become? What is x? 6p. X 6p minus 1. Again x 6p minus 2. Done. Now what happens? In this case 6p I have taken as it is. 6p minus 1 we cannot take any common factor, keep it as it is. But in 6p minus 2, 6 and 2 it is a multiple of 2, right? It goes under 2's table, so we can take 2 common. 2 3s are 6, p minus 2 1s are 2. Now what are the products are left out? 6p into 2, that is 12p. 12p into 6p minus 1 into 3p minus 1 is divisible by 6. So this is a product which is divisible by 6. One more case, let x is equals to 6p plus 1, next positive integer. So what happens? X into x minus 1 into x minus 2 is equals to, what is x? 6p. X minus 1, 6p minus 1, x minus 2, x is 6p minus 2. Similarly 6p into 6p minus 1, 2 common. Are you getting, children? Just a minute. What is the value of x? The value of x is 6p plus 1. This is x, right? X is 6p plus 1. Again x is 6p plus 1, x minus 1. Again x is 6p plus 1, then minus 2. Sorry, okay. 6p plus 1 into plus 1 minus 1 get cancelled. Left out is 6p. Then again 6p plus 1 minus 2 is minus 1. So product is 6p into 6p plus 1 into 6p minus 1 is divisible by 6. This is a product which is divisible by 6. One more case, because 3 consecutive integers, right? So let x is equals to 6p plus 2. So x into x minus 1 into x minus 2 is equals to, x is 6p plus 2 into 6p plus 2x minus 1, x 6p plus 2 minus 2, x into x minus 1 into x minus 2, that is 2 common, 2 3s are 6 plus 2 1s are 2. Then here 6p, 2 minus 1 is plus 1 into 6p, because plus 2 minus 2 get cancelled. So what are the outside terms? 2 into 6p, 2 6 are 12p into 3p plus 1 into 6p plus 1. So this is the product which is divisible by 6. Are you getting, children? So hence we have solved 3 cases. So what is option 1 of case 1, which is divisible by 6? Which is divisible by 6? 12p into 6p minus 1 into 3p minus 1 is divisible by 6. Case 2, 6p into 6p plus 1 into 6p minus 1 is divisible by 6. If you are going to substitute any value in place of p, that answer will be divisible by 6. This is the general standard form. Okay. Then 12p into 3p plus 1 into 6p plus 1 is divisible by 6. Thank you. I hope you all have understood these problems. We try one more problem and I'll be giving you still more. If you want, I can give you still more problems. You can try. But don't miss any of these questions, children. Let me solve one more problem. See, children, the next problem here. Prove that if x and y are odd positive integers, if x and y are odd positive integers, then we have to prove x square plus y square is even. Okay, the solution what we are getting, make sure that it should not be divisible by 4. That is what we have to prove here. Okay, so let it, x and y are what? Odd positive integers. So we can assume here, since both are odd positive integers, so let x is equals to 2m plus 1. Okay, and y is equals to 2n plus 1. I am going to assume x as 2m plus 1 and y as 2n plus 1. We can see here x square plus y square, squaring. What we are doing for x and y, we are squaring, right? So I will do one thing, squaring on both sides for both x and y, squaring on both sides. So what happens? X square is equals to 2m plus 1 whole square, right? And y square is equals to 2n plus 1 whole square. Shall we add both the sides? X square and y square, can we add? Yes. If we add x square plus y square, what answer we get? That is even, it seems. If you add this now, x square and y square, the answer is even. But that product, the answer is, the solution should not be divisible by 4. That we need to remember. Anyhow, let's see. X square, what is x? X square, 2m plus 1 whole square, plus y square, 2n plus 1 whole square. It's in the form of a plus b whole square. Yes, that is a square plus 2ab plus b square. So shall we apply this a plus b whole square? A square 2m whole square plus 2 into a 2m into b is 1 plus b square, that is 1 square, plus this is x square plus y square. Okay, 2n whole square, a square plus 2 into a into b plus b square. 2m whole square is 4m square plus 2 2s are 4m plus 1 plus 4n square plus 4n plus 1. Now I will rearrange the terms in the standard form, second degree, first degree and constant. So what happens? 4m square plus 4n square plus 4m plus 4n plus 1 is 2. Now from this both, what I can do here, in m square plus n square, can we see here, in m square and n square and m and n, in this both, can I take 4 as common? If I take 4 as common, what happens? M square plus n square plus again 4 as common factor, then m plus n, then plus 2. Done. So again what we can do from this both now, can we take 4 as common? So what happens? M square plus n square plus m plus n, close the bracket, plus 2. We can assume this as 4q plus 2. Okay, that is x square plus y square, where, because what is q? Q is equals to m square plus n square plus m plus n. We can see here the product what we have got, that is not divisible by 4. You can assume q as 1. Example, 4 ones are 4q plus 2. 4 ones are 4 plus 2. 4 plus 2 is 6. Is 6 is divisible by 4? No. 4 2s are 8. 8 plus 2 10. 10 is divisible by 4? No. 4 3s are 12. 12 plus 2 is 14. 14 is divisible by 4? No. So hence we also have proved that this product is not divisible by 4. Understood? So hence proved the product is even but not divisible by 4. So thank you children for watching this video, and these are the basic problems, condition based problems which we have done. Okay, should not forget any of these classes which we have done till now. Wish you all the best of luck. Don't forget to like, comment and subscribe. If you are finding any doubts, so please you can ask me, you can share your doubts with me. I'll try to help you all. Okay, wish you all the best of luck. Thank you.